All right, today we're going to look at more solving linear inequalities in two variables by graphing. So what we've seen before is we've been given an inequality such as x is less than 1. We have graphed it on a number line. We know it would be an open circle because 1 cannot be included because 1 is not less than 1. It is equal to, but we needed somewhere to start. So we put this open circle on 1, and then we shaded everything to the left. So that means any fraction in between 0 and 1. So, for example, 3/4 could be in there. This could be negative 0.05. And that's why the whole line's shaded, because it's more than just the whole numbers 0, -1, -2, and so on. So what we're doing now is we are taking this ideal from what we've done with the number line, and we're putting it on a coordinate plane. So we are graphing the line. So instead of having this inequality, x is less than 1, we would graph the line x equals 1, such as they've done here. We know x equals a vertical line. We made it a dotted line because we can't include anything on that point, on that line, any points on that line to be the answer. But everything over here that is shaded to the left could be an answer. And so now we're starting to look at more than one variable. So a linear inequality describes a region of the coordinate plane that has a boundary line. So the line that we draw is called a boundary line. We're cutting the plane in half and shading half of it. And the solutions of the inequality are the points that make it true. So in this case, the line would not be included, but any point out here that is in the shaded region is an answer. So if it is a solid line, then we can include these points that are on the line. They are part of the solution in addition to every point that is out here in this shaded area. So here is an important table for you to look at. This is talking about linear inequalities. You shade above when you have the greater than sign, right here, and when you have the greater than equal to sign. So that means when you solve for y, if it is open towards the y, that means y is bigger, and you need to think bigger means above. So for either one, either symbol, if it is open towards the y. Then you need to shade below if it is less than. So if you solve for y and it is not open towards the y, that means y is smaller. So you need to shade below the line that you draw, whether it is less than or less than equal to. Then you have dotted lines for both of these symbols, the greater than and the less than, because the line cannot be included because it does not say equal to, so it is a dotted line, much like the open dot on the number line. So then the solid lines have to be equal to, and we could actually, in fact, draw in one more box down here and put the equal sign in there. Because all three of those, greater than equal to, less than equal to, or equal to, are just regular solid lines that we are used to drawing when we draw lines. So when graphing a linear inequality, you need to solve the inequality for y equals, or if it is x equals, leave it the way it is written. So that means if I only had 4x is greater than or equal to 5, I can only solve that for an x equals. Whereas if I had 4x plus 2y is less than or equal to 10, this one I would solve for y because it has a y in there. You need to use the symbol to decide whether the line is dotted or solid, and whether you shade above or below. So we did that yesterday in some examples, we were able to determine dotted solid above or below before we ever started graphing. And then you graph the boundary line. You simply graph the line that you have solved the equation for. Then shade the solution region. And then, of course, you always want to test a point to verify your work. So let's work through some examples. This one is an easy example. Already solved for y. Check. So step 1 is let's solve it for y if it's not already done. So done. Step 2 is let's determine solid or dotted. So when I look for solid or dotted, I have to look at the symbol. So here's our symbol. It's a greater than equal to. So it is equal to, because of that line right there, I can write the word solid. When I graph this, it's going to be a solid line. So then step 3 was, let's determine where to shade, above or below. So this is open towards the y, meaning y is bigger. So that means I need to shade above the line that I draw. So we have a couple of options for actually drawing our line. We can know that this is the y-intercept, so we go to the y-axis at a positive 5 and put a point. And we know that the slope is 6 over 5. 6 is positive, so that means let's go up. 5 is positive, so that means let's go to the right, because it is rise over run. So from this point, I should go up 6, but I run out of room on my graph. So that means I need to change the direction. So I should also know that a negative over a negative would give me that positive 6 over 5. So that means I can go down 6 and to the left 5 from my y-intercept. So here we go. 1, 2, 3, 4, 5, 6. To the left 5. 1, 2, 3, 4, 5. There is my second point. I'm connecting it with a solid line. This is where if you have a ruler, rulers are really great and helpful, especially when your points are spread out like that. And we said we're going to shade above that line. So that means my answers are on that line, or they are in this area that I have shaded. So then step 4 was graph the line, which we did. And then step 5 is let's check our shading. So if I pick a point, that point is negative 3, 4. I plug that back into my original equation to see if it works out. So is 4 greater than or equal to 6 over 5 times negative 3, because 4 was the y value, negative 3 was the x value, plus 5. So I can check in my calculator, and if you don't have a graphing calculator at home, you can simply Google Desmos graphing calculator, and we can type it in. So our problem was 6 over 5 times negative 3. So I need to put that in parentheses as 6 divided by 5, close parentheses, times negative 3, and it was plus 5. Hit enter, it tells me that my answer is 1.4. So is 4 greater than or equal to 1.4? Yes, it is. That's a true statement. 4 is greater than 1.4, so I have shaded the correct region. So let's work through an example of x is less than negative 5. So step 1, I need to solve it. Well, it's already solved. We only have one variable. It's already isolated by itself. So step 2 was let's determine solid or dotted. This does not have an equal sign. It is less than. So that means numbers on the line, points on the line are not solutions, so it needs to be a dotted line. And are we going to shade above or below? Well, it is less than. It is not open towards the x. X is smaller, so smaller means we need to shade below. But what happens is when we look at this, x is -5 here at all these points here. We should know that x equals anything gives a vertical line. So we can go ahead and connect it with our dashed or dotted line. And we said let's shade below. Well, there's no below. There's a left or there's a right of the line. So think of it this way. It's like your number line. If you would have shaded this on a number line, it would have been an open circle, dotted line, and we would have shaded to the left because all the numbers smaller than -5 are to the left. It is the same thing here. All the numbers smaller than x are still to the left. So I would shade this region over here. And then we could pick a point and check. Number 3 has solved for us. If you look at the symbol, that is a less than or equal to, so that means it's going to be a solid line. It is already solved for y, so I can go ahead and graph that line. That is -x. And since there is nothing written there, that means we need to start at the point 0, 0. It doesn't have a y-intercept written out, so it is understood to be +0. So we start at 0, 0. And then from there, you could go down 1 to the right 1, because the slope is -1 over 1, as she's talking about over here. We connect all the points, and then this we shade below. It's not open towards the y, so we shade below, and this whole area, including the line, is our solution region. So let's look at one then where we actually need to solve for y. We did a lot of practice with these prior to this unit, but let's make sure that we know how to solve for y. So here is y. We need to get it by itself. It's being multiplied by 2 and having 5x added to it. So we first have to move the 5x to the other side. So it's a positive 5x, so we are going to subtract it. So that becomes -5x minus 10, because we can't combine those terms in any way. They are not alike. Then we need to divide by 2. So we can divide everything by 2. And this is where some people choose to stop, because they can take this and we can type this in our calculator and get points for our line. Some people choose to go on and simplify. -5 divided by 2, we're going to leave that as -5 over 2 and put the x beside it. And then -10 divided by 2 is a -5. So some people like to graph it from the slope-intercept form. Okay, so if we're looking, let's look how we would graph it if we stopped here. So if you went to your calculator, you would go to y equals, or if you're using Desmos, you would type y equals into Desmos, and it is -5x minus 10. We want that whole thing divided by 2, so when we type it in, we want to put it in parentheses. So -5x minus 2, oh, it was minus 10, excuse me, divided by 2. To get divide, you hit the backslash button. And so this is our line. So how do we take that line and translate it onto our graph? Well, if you click the settings and then click table, it provides us a table with points. So it is saying I should have a point at -2, 0. Well, it shows me on this graph where -2, 0 is. So it makes it even easier to come over here and go to -2, 0, put a point. And then it says I have a point at 0, -5. So if I click that point, that shows me 0, -5. So that shows that I should go here, 0, -5. And those 2 points, we should connect, if we look at our symbol, we are going to connect with a solid line because of the equal sign underneath. And when we solve for y, it was still open towards the y, so we're going to shade above. If we look to our original problem, it's open towards the y right here before we solve, so it looks like we should be above. And if we check the number in front, that's a +2, so I know I'm not going to flip my symbol, so it's still going to stay above. So let's go back though and connect our 2 points with a solid line. And it lined up better with my points. We need arrows on the end, because the line goes on forever. And we are going to shade above. And so in this case, above is kind of more over here to the right. And it doesn't have to be completely colored in, completely gray. It's just so that we get the idea that you're shading over here on this side, that this side is the solution region. And if we want to check and make sure, 0, 0 is right here, so that's a great point that I can take and sub in. So what is 5 times 0 plus 2 times 0? Is that greater than or equal to -10? Well, 0 plus 0 is 0. So is 0 bigger than or equal to -10? Yeah, 0 is bigger than -10. And then our last example is worked out for us. So if we immediately look at this symbol, it has an equal sign, so it should be a solid line. It is not open towards the y, so it kind of looks like maybe it's below, but I notice that there's a negative in front of this y. So it means I'm going to have to divide by a negative, and when solving inequalities, I know the rule to divide by a negative means I have to flip the sign. So if I flip that sign, it's going to be open towards the y, so that makes the shading above. Or I can go ahead and I can solve it out, like over here, subtract the x from both sides. So then I have -y is less than or equal to 3 minus x. Then I have to divide by -1, and when I divide, my sign flipped. So when I look down here, it is open towards the y, so I know to shade above. So I can graph that line. So I can go back to my calculator if I need to, and type in y equals, the TI-84s you don't have to type in y equals, but on Desmos here we do, y equals -3 plus x. And then I can click the settings and click table, and it pops up points. I have a point at 0, -3. So if you see here, there's a dot at 0, -3. I have a point at 2, -1. On here, there's a point at 2, -1. And that was enough to connect the dots. You could have drawn more with a solid line. And I know I have to shade above, so this is my solution region. So then this red dot represents a point in the solution region. And so I can take that point 0, 0, and I can substitute it into my original. I always want to put it in my original, not anything that I created, but what was given to me to check my answer. So when I substitute it in, 0 minus 0, is that less than or equal to 3? Well, yeah, 0 is less than 3. It makes a true statement. So I have shaded the correct region. So that is additional notes and additional practice on solving linear inequalities in two variables by graphing.